Right. Summing amplifier. Summing amplifier, there are two modes, right? That means you know about inverting amplifier and you know about non-inverting amplifier, right? But here I have added one term, that is summing amplifier. Now inverting summing amplifier and non-inverting summing amplifier. What is this, right? It is basically an inverting amplifier, but what it is doing, it is performing some addition operation or summing operation. That means this is a non-inverting amplifier, inverting amplifier. Therefore, non-inverting input terminal is grounded, okay. And then at the inverting input terminal, you want to add two voltage sources, right? Maybe V1 and V2. Otherwise V3. N number of voltages you can add. Okay. So, but it is connected. All these input voltages, these are connected to inverting input terminal. So at the output, what we get? Sum of all the inputs, but it is with minus sign, right? Sum of all the inputs. It may be one or two inputs, or it may be three inputs, like that. So this is the meaning for the heading inverting summing amplifier. It is summing amplifier which performs sum, which performs addition, right? Then as the name implies, it is non-inverting summing amplifier. It is also a summing amplifier. You can connect it in non-inverting mode, but still it will act as a summing amplifier. It performs addition. So these we are going to study in today's class, right? This is what we are going to study in today's class. Summing amplifier, which performs sum and it will amplify, right? It performs sum and it will amplify. Summing amplifier. It may be inverting or it may be non-inverting. So here in this class we are going to design these summing amplifiers, right? The knowledge what we have acquired in op amps, that we are going to use for the design purpose, right? Right. For the design purpose, we are going to use. That means we are going to design a inverting amplifier or non-inverting amplifier. I think in this class, with the available time, we will be able to discuss inverting summing amplifier with one example problem. And in the next class, if possible, we will discuss today's class itself non-inverting summing also. Otherwise, we will discuss in the next class, right? Now let us see, this is the inverting summing amplifier. Inverting summing amplifier. Just some compensation resistance. So you just small resistance. We need not what is that? Do any analysis for this. You just treat it as ground. Some small compensation resistance we are connecting at the non-inverting input terminal. At the inverting input terminal, we know I have mentioned just now three inputs through some resistance R1, V2 through some resistance R2, V3 through some resistance R3. So three input voltages we are giving to the inverting input terminal of op amp. Okay. Then output of this op amp is fed back to the input through a feedback resistor, and this is the connection, right? So this is, I told you now, I'll for the sake of simplicity, I am not going to show this plus VCC minus VEE between what is that, offset null between 1 and 5 points. All that for the sake of simplicity we are not indicating here, but you have to indicate all that, right? So even if you do not indicate, no problem. In the examination you will be having 3 hours time. So maximum possible information you can place on your answer sheet. Okay. So now let us see, for such a circuit, how do we obtain what is the output? Simply if I say this is summing amplifier, then you need not buttify it. Okay, you need not buttify it. You have to analyze and you have to verify whether you are getting V0 as what we say, sum of the inputs or not. We are going to verify. We are going to verify. Let me see. Now let us consider the node. What is this line? I think some double click. 1 second. Let me. I think whether this line is right. Okay. Okay. Right. Now let us see how we can express V naught. How we can express V naught. Okay. For that, let us consider this node A. At this node, let us write KCL. KCL. We know what is that? All the currents meeting at node is equal to the algebraic sum of currents meeting at a junction is equal to 0. Otherwise, currents entering into a node is equal to sum of currents leaving. Anyway, you can say, now let us take this A, node A. At node A, let us write KCL, right? That's what I have mentioned. Voltage at node A, right? What is that? Voltage at node A is 0 because non-inverting input terminal is grounded. Let me also mention this. This non-inverting input terminal is grounded. Therefore, here we say that the voltage at this point will be same. That means it is also at ground, we can say. Now, if this is ground, then you can take what is the what is you can consider this as ground point, means it is a zero potential point. Okay. Now, what is this current? You can write V1 by R1. V1 by R1. If there is some voltage, then what we do? V1 minus voltage at VA by R1 we will write, because this other terminal is grounded. This terminal also will be like ground. Therefore, here zero potential. Therefore, V1 by R1 plus V2 by R2 plus V3 by R3 is equal to V naught by RF. V naught by RF. Otherwise is equal to minus V naught by RF. Otherwise we say V1 by R1 plus V2 by R2 plus V3 by R3. Either minus V naught by RF or plus, bring that V naught by RF this side. You will get what is that? V naught is equal to here minus, na? Here we will get minus voltage, right? So therefore, minus V naught by RF. Otherwise, you bring this side plus V naught by RF. Now here you take V naught common, and again it goes to the other side, minus of RF by V naught by RF, no? So this RF is multiplied with all the terms. So V naught is equal to minus of RF by R1 into V1, RF by R1 into V1 plus V2 RF by R2, V3 R3, V3 RF by R3. Just you rearrange this equation. That means the same equation you try to express in terms of only V naught, right? This equation you express only for V naught. V naught is equal to this much. So, are you able to write this equation or not? Are you able to write this equation from this KCL?
Yes,
Are you
ma'am.
right? Very good, very good. Right? V naught is equal to RF by R1 into V1 plus RF by R2 into V2, all that. Now, okay, now we can write V naught. Okay, now from this equation you can say that output is equal to V naught is equal to minus of RF by R1 into V1 plus all this. That means output is some minus of sum of voltages V1, V2, V3, right? That's why we call it as sum. Of course, RF by R1, RF by R2, RF by R3, this is called weighted, what is it? Weights of this term. So, finally we say that output V0 is equal to weighted sum of the inputs. Output V0 is equal to weighted sum of the inputs, right? Now, that is what about V0. Okay. Now, different cases we are going to consider. different cases we are going to consider. That means if R1 is equal to R2 is equal to R3 is equal to RF, if R1 is equal to R2 is equal to R1 is equal to R2 is equal to R3 is equal to RF. So here we write RF, RF, RF. So RF by RF 1, so V1, RF by RF V2, RF by RF V3. So finally V0 will become minus of V1 plus V2 plus V3, right? If some special case, that is when R1 equal to R2 equal to R3 equal to RF, that means feedback resistance and all the resistors in the circuit are same, then we can say V0 will be the direct sum of, right, sum of inverted sum of what is that, all the input voltages V1, V2, V3, right? That's why we call this as a inverting summing amplifier. Why inverting? Because of this minus sign. Why summing? Because of the addition of V1, V2, V3. So this is what about what is that, inverting summing amplifier. Okay. Now let us also see another case, that is we can also set R1 equal to R2 equal to R3 equal to 3 times RF. When we write 3 times RF, what will happen? Let us see this equation, right? This equation. R1 equal to 3 times RF. So RF gets cancelled and 3 will be there. That means V1 by 3 plus R2 is equal to 3 times RF. So 3 RF gets cancelled, V2 by 3. And R3 is equal to 3 times RF. So 3 will be like that. And RF gets cancelled. So 1 by 3 into V3. That means V0 is equal to minus of V1 by 3 plus V2 by 3 plus V3 by 3. Right? That means denominator is same. So you can write V1 plus V2 plus V3 by 3. That is what we want to show here. So V0 is equal to, in such a special case, right? If there are 4 resistors, you try to take, right? That means we are designing means we are going to select the values, right? Till now we have studied whatever is existing. With that knowledge, now we are going to design our own circuits, right? Let us see, when R1 equal to R2 equal to R3 equal to 3 times RF, then V0 is equal to this much. So it is a minus inverting amplifier, and it is now V1 plus V2 plus V3 by 3 means it is average. Three voltage sources and their average. Now we can say that the output is the average of the input signals inverted, right? So like that you can design a summing or inverting summing amplifier, right? We are coming to the end of the class. Let me give you one small simple problem so that you can understand how we design an adder circuit or a simple inverting summing amplifier circuit. Okay, all of you please note down this example problem, that is design an adder circuit. Design an adder circuit using an operational amplifier to get the output expression as V0 is equal to minus of 0.1 times V1 plus V2 plus 10 times V3, where V1, V2, V3 are the inputs. So I told you just now, with the knowledge that we have gained, we are going to design some circuits. This is a summing amplifier we are going to design. It is an inverting summing amplifier. Actually, it is not mentioned whether we have to design an inverting summing amplifier or non-inverting summing amplifier. It is not mentioned. Just it is mentioned that design an adder circuit using an op amp to get the output expression as V0 is equal to minus of some of these terms. Because we see this minus sign, we understand that it is an inverting amplifier. So what you have to do first, you have to draw the circuit. All of you, please draw the circuit here. This terminal is grounded, non-inverting input terminal is grounded, and at the inverting input terminal, you draw three resistors, right? Because V1, V2, V3, three voltage sources are there, three inputs are there. So V1, V2, V3, three voltages you give, V1, V2, V3, right? And you should have some feedback resistance RF. So this is feedback resistance. Feedback resistance. Now you have to get, for such an arrangement you have to get minus of all these values. Okay, that means this is the circuit that they are asking. Design an adder circuit using op amp to get the output expression as given here, right? So for that, just inverting summing amplifier is expected. So all of you draw this inverting summing amplifier. After drawing this summing amplifier, you have to just give them names. This is R1 and R2 and R3. R1, R2 and R3. Right. Now, while design, what do you mean by design an amplifier circuit or a adder circuit or any circuit? That means, design means what? You are going to identify. Op amp, you are not going to do anything, right? It is already designed op amp. You are using that op amp. So what should be the value of RF that you have to select? What should be the values of R1, R2, R3? Only these parameters you have to calculate or you have to design, because V1, V2, V3 are different voltage sources, different inputs. So for that also you need not design anything. Only thing what you have to do is, what are the values of resistors R1, R2, R3 and RF that I have to select for getting this expression. To get this expression, what are the values of resistors that I have to select? That is what is expected here, right? Now this is called design. So in this design, let us assume that RF is equal to some 10 kilo ohms, because it is a what is that? It is a problem common to the entire class. If it is in the examination, you can assume any value. You can assume any value. Now, in order to drive you in the same direction, I am asking all of you to select RF equal to 10 kilo ohms. All of you select RF equal to 10 kilo ohms, right? Now, you have output expression. What is that output expression? V0 is equal to minus of V1 into RF by R1 plus RF by R2 plus RF by R3 into V3, right? That means here you take each one of these components. Now it is only V2, let us take. V2 into RF by R1 should be only 1. So that means V2 into RF by R2 is equal to 1. That means RF by R2 equal to 1 means what? RF by R2 is equal to 1 means what? If RF is equal to 10 kilo ohms, let R2 also be 10 kilo ohms. Then 10 kilo ohms by 10 kilo ohms, you will have 1. So that 1 will be here, and directly you can say V2 coefficient is 1. So R2 value, if you select RF value 10 kilo ohms, R2 value also should be 10 kilo ohms. Is this example clear to you or not? Is this clear to you or not? V2 coefficient is only 1. That means this is output expression. V0 is equal to minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3. Now RF by R2 is equal to 1 only in the expression, right? In our expression, it is 1. That's why I have chosen that. Okay. When it is 1, That means whatever value of RF you have, if you select same value as R2, then both gets cancelled and you will get V2. So in our given question, what is the value of RF? If we assume RF is equal to 10 kilo ohms, in the examination everybody will not select same value. Any value you can select. Corresponding to RF equal to 10 kilo ohms, R2 will be also equal to 10 kilo ohms, because in the expression V2 there is no coefficient for V2, it is unity. Therefore, we say RF is equal to 10 kilo ohms means R2 is also equal to 10 kilo ohms. Is it clear to you or not? Are you able to calculate the value of R2 from RF?
Yes, ma'am.
Yes. Okay. Good, good. Now you tell me what is the value of R3. All of you tell me what
R3 equal to 100 ohms, ma'am.
R3 is equal to
100 kilo ohms.
100 ohms, ma'am.
Then what is R1?
R1 equal to 100 kilo ohms, ma'am.
R1 is equal to 100 kilo ohms. If R1 equal to 100 kilo ohms, how come R3 will be 100 kilo ohms? Here it is 10, here it is 0.1.
Ma'am, R1 equal to 100 kilo ohms, ma'am. R3 100 ohms, ma'am.
Okay, right, sorry. Now let us see. R3 100 ohms you said, you just verify. R3 is equal to 1 kilo ohms. R1 is equal to 100 kilo ohms. You just verify. If RF equal to 10 kilo ohms, if RF equal to 10 kilo ohms, same way how we have written now. That means RF by R3 is equal to how much for the first one? 0.1, right? V1 coefficient only, no? So RF by R3 is equal to 0.1. R3 is equal to RF by 0.1. R3 is equal to RF 10 kilo ohms divided by 0.1. 0.1 means into 10. So 100 kilo ohms. RF by R1, no, it is R1. RF by R1 is equal to 0.1. So R1 is equal to 10 kilo ohms by 0.1. It is 100 kilo ohms. So did you get R1 100 kilo ohms or not?
Yes, ma'am. Got, ma'am.
Right. R1 100 kilo ohms. One of you please tell me what is R3 value. Just how I have mentioned, you please tell me. That means RF by, one of you tell me like this, RF by R3 is equal to 10. Like that you explain, ma, what is the value of R3? Any one of you in your words.
1, ma'am. 1 kilo ohm.
RF by R3 is equal to 10 kilo ohms. Sorry, 10. RF by R3 is equal to 10. R3 is equal to RF by 10. RF is 10 kilo ohms. So 10 kilo ohms by 10, it is 1 kilo ohm. 1 kilo ohm only, right? R3 equal to 1 kilo ohm. Now, if you substitute these values and write expression for that, you will get the desired output expression, right? Is it clear? Is this clear to you or not?
Yes, ma'am.
Yes. Okay, it is very small, simple problem only, right? Summing amplifier. Okay, so this is what about summing amplifier. I want to give you another problem actually. Shall I give you another problem?
Yes, ma'am.
Yes, ma'am.
Okay. We'll do many other problems also. I think one of you can tell me what is output expression. Let us just modify output expression and all of you can draw the circuit. Okay. So one of you, any one of you who joined this class today first, Who joined this class first time? I mean, first person. I saw that number, I forgot. Every day I see, no, I forgot today. So any one of you give me an output expression so that everybody will do that problem, right? That means design an adder circuit using op-amp to get the output expression as V0 is equal to minus of, you tell me the expression, any one of you. Soon, because
V1 plus V2 plus V3 by 3, ma'am.
V1 plus V2 plus, who is that, ma? Tell me your name, please.
Geeta, ma'am.
Geeta, very good. V1 plus V2 plus V3 by
V3 by 3, ma'am.
V3 by 3 means, let us write it as point. Here only or total by 3 you are saying? Okay, 0.3 times V3. Okay, so for this expression, you design to get this output expression, all of you design, what is that? Adder circuit. Here I am thinking to make it more simplified, I am trying. Okay, 0.1, okay, let it be 0.3, no problem. So all of you, person, who is that? Geeta, you tell me what is the value of RF that people have to assume. You give some RF value also, so that all others will calculate R1, R2, R3 values.
Ma'am, 100 kilo ohms, ma'am.
100 kilo ohms, good, right. Emma, all of you consider 100 kilo ohms as feedback resistance, and you calculate. Why I'm actually in the examination, nobody will say that you have to assume RF value this much. In order to maintain same answer from all the students, I am giving you this RF value. Okay, output expression and RF value. In the examination, you will be asked to give, you will be asked to design the adder. That's all to obtain this expression. Okay. Okay, when RF equal to 100 kilo ohms, what is the value of R1, R2 and R3 to obtain this expression? What is the value of R1? What is the
100,
value? Are you calculating for R1?
100K, ma'am.
Same as RF. So you need not calculate. R1 you need not calculate because there is no quotient here. No, there is no, what is that? Multiplication factor here. So when we have this term directly, you can say RF by R1 is equal to 1. That means whatever RF you have, same R1. So R1 equal to 100 kilo ohms. Then what is R2?
100 kilo ohms, ma'am.
Same, because right, R1 is equal to 100 kilo ohms, R2 also is equal to 100 kilo ohms. Then what is R3? What is R3? That means RF by R3 is equal to, my God, RF by R3 is equal to 0.3. How much it is?
333 kilo ohms.
3? Calculate carefully.
333.3 kilo ohms, ma'am.
Very good, very good. Okay, that means what is that? RF by R3 is equal to 0.3. Now you can calculate R3. It is R3 is equal to how much? One of you explain how I am telling now. Same way, one of you please give complete explanation. One of you please give complete explanation. how I am showing now, similar to that. I think you too can explain, but of course you need not show, you just express in words. We will be able to understand, any one of you. Rf by R3 is equal to 0.3, right? 0.3. Then R3 is equal to Rf by 0.3. That means 100 kilo ohms divided by 0.3 means 3 denominator into 10 here, right? 10. Am I correct? So this is,
Yes, ma'am.
yes. This is how much? 33.33, like that you will get. So what is the final value? What is the final value of R3?
333.3 kilo ohms.
Right. 333.333 kilo ohms. So like that you can design an adder circuit. Okay. So in today's class, of course, in the next class, we are going to discuss about non-inverting summing amplifier. Okay. Here it is a summer that gives non-inverted sum. That's all. That's why it is called as non-inverting summing amplifier. Because you got some idea on summing amplifier, in the next class we'll discuss about non-inverting summing amplifier and also a subtractor, right? Just rearrangement of these values, that's all. Same adder can be used as subtractor also by proper selection of the resistors. But next class we shall discuss about non-inverting summing amplifier, right? So let me recollect once what is this summing amplifier. Summing amplifier, it is inverting summing amplifier and non-inverting summing amplifier. It performs sum or addition, right? And this is the circuit, and for this circuit we have written nodal equation that is at this node. Only thing that you have to understand is this is the node when non-inverting terminal is grounded. So here this point also is equal to ground potential, because the voltage difference between this point and this point is ideally 0. That's why we call this as virtual ground, right? And therefore actually through this branch, if you want to have current V1 minus VA divided by R1, we write, because it is 0 potential, ground potential V1 by R1 plus V2 by R2 plus V3 by R3, and this side minus V0 by RF equal to 0. That's what we have written. Minus V0 by RF, you bring it this side, plus V0 by RF, you rearrange this equation, that's all. And special cases we take, right? When all are equal to RF and they are equal to 3 times RF, that's all. Okay. And we have designed a small simple problem. So with this I stop here for today. In tomorrow's class we shall discuss about non-inverting summing amplifier. Not tomorrow, of course, on Sunday. Then again on Monday also I have MSET duty, so I will be on OD on Monday. That class is adjusted to some other class teacher, maybe LICA or some other subject. So they will be taking, you will be given information, and after that again on Tuesday we shall meet. Okay. So just wait for a while. Let me take your attendance also, download attendance, and I stop my recording, and all of you can leave.